Now, let us see this formula, Euler's formula, by which we are going to verify whether we can easily find out faces, edges and vertices, and what we have found out is actually correct or wrong. Now, I have written 4 figures in front of you, that is cube, cuboid, triangular prism and triangular pyramid, and I have shown you how these figures look like. Now, I have made a table here with the number of faces, edges and vertices, and this is the Euler's formula, that f minus e plus v should always be equal to 2. Now, how do we find the faces, edges and vertices? Just for repetition sake or revision sake, we can say that a cube is a figure in which all the sides are identical and all of them are squares. Now, if you count the number of faces, it is 1, 2 top and bottom and 4 walls. So, 4 plus 2 6. Edges, we have 4 here and 4 here and another 4 here, 1, 2, 3 and 4. So, that is why we have 12 edges, and these are the vertices 1, 2, 3, 4. So, 4 here in front of you and 4 here behind this. So, we have 8 vertices. So, we have 6 faces, 12 edges and 8 vertices in case of a cube. Now, let us verify what we have found out is correct or wrong, that is by using Euler's formula. F minus e plus v should give us 2. So, when I am going to apply that formula in the first case, so I am going to add f and v, that is 6 and 8, 6 and 8 is 14 and therefore, we get 14 minus of 12. So, we are going to get here the result as 2. That means, what we have found out here, faces, edges and vertices is correct. If you look at the next figure similarly, that is a cuboid. Now, look at the cuboid here. In a cuboid also, we have 6 faces, that is 1, 2 and then we have here 4. So, 4 here, so 4 plus 2 we are having 6 and then similarly we are having edges, that is 1, 2, 3, 4 here, 4 behind and 4 on the sides, that is why we have 12 edges, and vertex 1, 2, 3, 4, 4 vertices here and 4 behind it. So, 4 plus 4 8. So, the number of faces, edges and vertices of a cuboid is identical to that of a cube. So, here also 6 plus 8 is 14, 14 minus 12, you are again going to get the result as 2. Next is the triangular prism. Now, in a triangular prism, when we calculate the number of faces, it is 1, 2, 3, 3 on top and 1 which forms the base. So, we have 1, 2, 3, this is a pyramid, 1, 2, 3, 4. So, 4 faces, and then we have edges, we have 1, 2, 3, this is 1, 2, 3 here and 3 below here, that is the base. So, we have 3 on top and 3 below, so that makes it 6. So, we have 6 edges, and what about the vertices? 1, 2, 3 and 4. So, we have 4 vertices. So, that is why we have 4 faces, 4 edges and 4 vertices. 4 plus 4 makes it 8, 8 minus 6 is also giving us 2. So, now we are left with a triangular prism, and what is this triangular prism we are talking about? It is a figure like this, where the base is a triangle and on the top portions you will have parallelograms and the base and top are identical. So, if you hold it like this, you will get a triangle here, and if you hold it here, this is also a triangle. So, these are identical portions. So, how many faces? 1 and 2 top and bottom and the 3 sides. So, that is why we are having 5 faces, and then the edges, we are going to see 3 on top, 3 below, that is 3 plus 3 is 6, and then we have 7, 8 and 9. So, that is why we are having 9 edges, and the vertices 1, 2, 3 and 4, 5 and 6. So, we have 6 vertices. So, when I am going to add 5 and 6, we get 11, and 11 minus 9, again we are going to get 2. So, in all these cases, we find that when we are applying this formula, Euler's formula, f minus e plus v is always coming out to be 2. So, we can say that Euler's formula is verified for these 3-dimensional figures.